In this video, we're going to discuss piecewise functions. We're going to explain how to evaluate a piecewise function and explain how to graph a piecewise function. So a piecewise function is basically when you create a new function by taking pieces of other functions. So for example, if I had the function x squared, and let's say I had the function square root of x. And let's say I wanted to take this piece here of the quadratic, so from 0 to minus infinity, I want to take that piece. And then let's say I want to take of the square root function, I want to take the square root function from 4 to 9. I want to take that piece. So then if I put those together, take those pieces and put them together in a new graph, it would look like this. Here's the quadratic function that's from minus infinity to 0, that piece. And then the piece of the square root from 4 to 9 would look like this. And this would be my piecewise function. And so I took pieces of other functions, put them together on a different graph, and created a new function. Now, the formula for that would look something like this. I list my pieces, which would be x squared and the square root of x, and then next to that I would describe the interval on which I kept that piece, the piece that I drew. So for the x squared function, I kept everything that was less than or equal to 0. That's this piece here, everything less than or equal to 0. And then for the square root function, that piece I kept, which was from 4 to 9. So I would list that here as x is between 4 and 9. So this part here, the second half, when we write this down, is the domain for each piece, or the x values on which that interval lies, and then this is the function. So let's go to the first example and we can discuss how to evaluate these. Okay, the key to evaluating them is to look at the interval that it lies on. So there, the first piece is the line negative x plus 2, and we're only graphing that piece on the interval where x is greater than or equal to 1. And then our other piece, our second piece, is x is less than 1. So if I ask you to graph in this first example, or evaluate f of negative 2, we want to look to see what the y value is when x is negative 2. So I need to look to see which piece does negative 2 lie on. Does it lie on this piece here when x is greater than or equal to 1? Or does it lie on this piece when x is less than 1? Well, since x is less than 1, because it's negative 2, right? It's less than 1. So it's going to fall on this piece here, which means I'm going to plug in negative 2 into x squared. So I'm going to take negative 2 and plug it into x squared, and that's going to give me a 4. Okay, now the second example, it says f of 3. I want to look to see which interval that falls on. Does it fall on the first interval or the second interval? The first interval says we're looking at all the values that are greater than or equal to 1, and the second interval says all the values of x that are less than 1. Since 3 falls on the interval where x is greater than or equal to 1, we're going to plug 3 into the first function. So I'm going to take 3, and I'm going to plug it in for this x, and I'm going to take -3 plus 2, which would give me a -1. Okay, the last part of this example, f of 1. So if x is 1 and I want to figure out what y is, I'm going to figure out which interval this lies on. Now here's the tricky part. I see 1 on both intervals. In the first interval, it says x is greater than or equal to 1, and in the second interval, it says x is less than 1. Since in the second interval, it's not including 1, then 1 has to lie on the first interval, where it says x is greater than or equal to 1. So I'm going to plug 1 into the first formula, or the first function, where it says -x plus 2. So I have -1 plus 2, so that would be 1. So the key is to looking at our intervals so I know which piece of the function to plug it into. Okay, second example. For the first piece, I have all the values of x that are less than -5. For the second piece, I have all the values of x that are between -4 and 0, including 0. And on the last piece, I'm looking at the interval where x is greater than 0. So for the first part of example 2, it says find g of -7. Well, g of -7 lies on the first interval because -7 is less than -5. So I'm going to plug in -7 into the first piece. So I'm going to plug in -7 plus 1, which will give me -6, and then I have to take the absolute value of -6, which is 6. The next example says g of 16. 16 falls on the third interval because 16 is greater than 0. So I'm going to plug in 16 here, and I'm going to get the square root of 16, which is 4. The next example is g of -1. Whoops. Let me fix this. Here we go. Okay, g of -1. -1 falls on the second interval, where -1 falls between -4 and 0. So I'm going to plug it into this function. Now this is just the constant function -2. So it's just going to be -2. G of -4.5. This one's a little tricky. If I look, -4.5 does not fall on any of these intervals. -4.5 is not less than -5. -4.5 is not between -4 and 0. And -4.5 is not greater than 0. If you notice, there's a gap between this interval and this interval, between the -4 and the -5. So there is no piece that covers between -4 and -5. So when you have something like this, where there is no value, you would just put DNE or undefined. Now, G of 0, that would fall on the second interval as well. If you notice, I have an interval that falls between -4 and 0, including 0. That's the second interval. The third interval is anything greater than 0. Now, the second interval is the interval that includes the value of 0. So we're just going to use the constant function -2. Okay, now, how do we graph piecewise functions? So what I like to tell people, to break it down, it makes this much easier to graph and make a table of points for each piece. So I'm going to call this piece number 1 and this piece number 2. And I'm going to make a t-table, an xy table for each piece. Now, for the first piece, we have the function y equals x, and for the second piece, we have the function y equals negative x. On the first piece, we want values of x that are greater than or equal to 0. So I want to start at 0 and just go bigger. So for my x's, I'm going to start at 0 and then pick numbers that are bigger. Now, if you notice, on the first interval, it says x is greater than or equal to 0, means I want to include the point 0. So what I like to do is when I draw my ordered pair here for x, y, I put a solid circle there to remind me when I draw this on my graph, it's got to be a solid circle to include 0. And then since we want everything greater than 0, that means when I draw this, I'm going to have an arrow on the other side because it's going to keep going to infinity. It doesn't say between 2 and 4, where I start at 2 and end at 4 and all the numbers in between. It says everything greater than a specific number, so I got to make sure I put an arrow on the other end. Okay, once I have my x value set up that I want to use, I'm just going to go ahead and plug it into my function for y and see what my corresponding y is. So if I plug in 0 here for x, I get out 0 for y. If I plug in 1 for x, I get out 1 for y. And I get 2 and 3 because it's just y equals x. Okay, so my table of values are done. Those values are done for piece 1. Now for piece 2, I have the function negative x. Sorry, I was getting sloppy there. Let me fix it. Y equals negative x. Now for this piece, number 2, I want all the values less than 0. So I want to go numbers smaller than 0. So I want to start with 0. And when I graph this ordered pair, I want to not include this, right? It doesn't include 0. So I'm going to have an open circle here. And since I want to pick numbers less than 0, I'm going to go in this direction. And then I want to keep going forever because it says all the numbers less than 0, so I'm going to put an arrow at the other end. Now, I'm going to plug in to get my corresponding values of y. When I plug in 0 for x, I get negative 0, which is just 0. When I plug in negative 1, I get negative and then a negative 1. So the double negative makes it a positive 1. And then the same thing goes with the negative 2 and the 3. The double negative makes it positive. Okay, so now we have our ordered pairs that we want to graph. Each of these tick marks are going to be worth 1. And I'm going to start plotting points here. So for the first piece, I'm going to graph the point 0, 0. So I'm starting over here to graph these points. I'm going to graph 0, 0, and that end point that I colored in, this here reminds me that I got to do a filled in circle. So a filled in circle at 0, 0, and then I'm going to plot the point 1, 1, and then 2, 2, and then 3, 3, and then an arrow on the other end. And now I'm going to work on this piece, and I'm going to start with 0, 0. Now for this one, it says plot 0, 0, but plot it with an open circle because we're not including 0 in there. So if you ever get it so that you have an open circle overlapping with a closed circle, you just keep it closed. If you have an open circle overlapping with an open circle, then it remains open. So I graph that endpoint, and then I'm going to graph point negative 1, 1, and then negative 2, 2, and negative 3, 3 with an arrow on the other end. And there, I've graphed both pieces, and I've completed my piecewise graph. Now, if you notice, this is actually the graph of the absolute value of x. This is how the absolute value of x is defined. It's defined by a piecewise function. I use the graph of y equals x. If I drew the whole graph of y equals x and not just a piece of it, it would be this whole line, y equals x. And then if I graph the line y equals negative x, the whole thing, it would look like this. But since we only want when it's positive, we only use what's above the x-axis, and we take off what's underneath, which is what leaves us with the definition of the absolute value, which is this piecewise function. And then we don't use this bottom stuff here, so I'll erase it again. I just wanted to show you how that works. Okay, next example. We have the function 2x minus 1 when x is less than -1. That's the first piece. And then the second piece is just the constant function 3 when x is greater than or equal to 1. So I'm going to draw a table for each piece. Piece number 1 and piece number 2. Piece number 1 is for the line 2x minus 1, and piece number 2 is just for the constant function y is equal to 3. For the first piece, we want to pick values so that it's less than -1. So I want to start at -1, but I want this to be an open circle since we're not including -1. And I want to pick numbers that are less than -1. So say -2, -3, -4. And then it keeps going. And then for the second piece, I want to pick numbers that are greater than or equal to 1. So greater than or equal to 1 means this, when I draw this, it's going to be a filled in circle. And greater than 1 means I'm going to pick 1, 2, 3, and 4. And then at the other end, it's going to be an arrow. Now, if I start plugging in points to find the corresponding values of y, if we look back at the first piece, I'm going to take -1 and plug it into 2x minus 1, and then I'm going to take -2 and plug it into 2x minus 1, etc., to find all my corresponding values of y. So when I take -1 and plug it into 2x minus 1, that gives me 2 times the -1, which is a -2, and then subtract 1, that gives me a -3. Then I get a -5, and then I get a -7, and then a -9. So those are all my corresponding y values for the first piece. For the second piece, it's actually pretty easy since it's just the constant function y equals 3. It doesn't matter what my x values are. I'm just going to keep having 3 for my y value. Okay, now we've got all of our points ready to go, so we're just going to go ahead and start plotting these. Okay, so the first point I'm going to plot is -1, -3 on the first piece, and I'm going to draw that with an open circle. -1, -3 with an open circle. Then -2, -5. Then -3, -4. Sorry, -3, -7. And then -4, -9. And an arrow going in the negative direction because it's everything less than -1. Okay, and then for the second piece, I'm going to plot the point 1, 3 with a filled-in circle. And then the point 2, 3, 3, 3, 4, 3 with an arrow going in the other direction. So here's piece number 1 graphed, and here's piece number 2 graphed, and now we're done. Last example. I have 2 pieces. All the examples so far we've done are 2 pieces. There can be functions that have 3 pieces, 4 pieces. It's all done the same way. You just have more pieces. So here's piece number 1 and piece number 2. For piece number 1, it's the graph of x squared, and for piece number 2, it's the graph of the constant function y equals 5. For the first piece, we're picking values greater than or equal to 0. And when I plot 0, it includes 0, so I'm going to graph that with the filled in circle. And then what I'm going to do is take all those x values and plug them into y equals x squared to find my corresponding values of y. And then because it's everything greater than 0, I'm going to have an arrow on the other end. For the second piece, I want to pick values that are less than 0. So I'm going to start at 0 with an open circle because I'm not including 0 here. And I'm going to pick values less than 0. So I'm going to go pick negative numbers and then an arrow on the other side. And then I'm going to find the corresponding values of y, which in this case, because it's a constant function 5, it's just going to all be 5s. And now we can graph this piecewise function. Let's see. The first thing I'm going to graph is on piece number 1, I'm going to plot the point 0, 0 with a closed-in circle because we're including that point. Then I'm going to plot the point 1, 1, 2, 4, and then 3, 9. I got to go up a few more spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So over 3, up 9. Whoops. I'm not very good at... This should have a curve to it because x squared. If I was using graph paper, it'd be a lot easier. Okay, that's the first piece. Piece number 2, I'm going to graph the point 0, 5 with an open circle. 2, 3, 4, 5 with an open circle, and then -1, 5, -2, 5, -3, 5, and then an arrow going in the other direction. So there's my second piece, and now we've completed our piecewise function.